All right, so we're going to hit 5.3 today, which is what we talk about logarithmic functions or logs. So as a quick FYI, we did exponential in 5.1. This would have been the graph for an exponential base 3. If we find its inverse, which means flip all your x and y's, you get this shape. Okay, this is actually the shape of a logarithm. Okay, exponential gets closer and closer to x is equal to 0. Logarithm gets closer and closer to y is equal to 0. Okay, and so we're going to have this equation. We're going to talk about that here in a little bit on how that works. Okay, so how do you evaluate a logarithm? The biggest thing here in evaluating the logarithm, okay, is, okay, I'm trying to get to, there we go. I'm going to annotate a little bit here for you. And let's go into red. All right, so a logarithm is stated here as y is equal to log, and that's base b of x. Okay, that actually comes from when I find the inverse of an exponential. And here we have an exponential as b, which is the base. Notice it matches up with this little b right here. Okay, b to an exponent, notice the y is over here, and then is equal to x. The number that the exponential is equal to is inside this logarithm. Okay, now a couple things. Little b, like right here, can't be, it has to be a number other than 1, and it has to be positive. Okay, x, this number over here is going to be a number at all times. It's always positive. Okay, so those are a few of the little things that we're going to talk about. So the first thing we want to do is we are going to show how to switch them. Okay, now here it talks about how to switch from exponential form to logarithmic form. When you do this, you automatically are solving for y. Okay, so if I have some base to an exponent, it becomes the base in the log, and the number over here, the x, becomes inside the log. The y is my exponent from the exponential form. Okay, so we want to convert. Now this does have the solution. This is out of your textbook, but we want to convert. We're going to show how to do this here real quick. All right, so this is exponential to logarithm. So we're going to go log, and this is my base. So it's going to be little number 2 of this number, 64, is equal to 6. Exponent on this side. Okay. So what I'd like to do here is, here's my base is 27. So this is going to be log 27. And what I always do is I go equal to, and then what's the exponent in this problem? The exponent in this problem is the 1/3. So it's going to equal 1/3. Okay. And then this number over here goes inside, like so. Okay. Just like 6 is my base, right? So this is going to be log base 6. And you got to write the base. Okay. The exponent is -2. So it goes equal over here to this side, -2. And then the 1/32, or 1/36, sorry, goes inside. 1/36. Now all these are true statements. Okay? So that's the easy way to color code it for you to get to these answers. Okay? So if you look here, here's my base, 13, so it's log base 13. Exponent goes on the other side of the equal sign, -2, and then the 1/169th goes in there. Okay, so can we go the other direction with this? Well, yeah, if you go one way, you usually can go the other way. Okay, so where's my base? Here's my base, 5. This was always my exponent, so it becomes my exponent is equal to the number inside the log, 125. Done. That's exponential form. If I look down this one, where's my base? Put that in parentheses. To what exponent? Exponent comes from the other side, and that's going to equal 16. Okay, so again, how do you kind of go through all those? Okay, and these will show you some things with them, right? So these are some examples that you can see through. Log base 5 to 25 is 2, because 5 squared is 25. So this is how you evaluate. Okay, and it does say log base 5 of 25 is not read as log base 5 times 25. It is, it's going to end up being an exponential rule. Okay, so if I want to evaluate, it says finding the unknown term in the logarithmic equation. So if I want to find this number over here, okay, I'm going to show you here. I like using this tool better. What's my base? 2. So this is going to be 2, and y comes from the other side, so that's my exponent. And all of these numbers are going to be ones you can find. So 2 to what exponent gives me 8? Well, it'll be 3. This one, 5, to what exponent gives me 1? Now, this one's a little tricky. Anyway, the only way you can get a 1 is the exponent has to be 0. And then this one, 7, to what exponent is equal to 1/49th? Well, there is a way to get to 49, right? 7 squared is 49. But I want the 49 on the bottom. Anytime I want the number to be on the bottom, that number that I'm trying to get on the bottom, I need to give the exponent a negative. So y is -2. Okay? So that's how you deal with those. All right. Now it says finding the unknown term in a different location. All right, so I'm going to find an unknown term here. So what am I trying to find? I'm trying to find the base. I'm trying to find a to what exponent? 5 is equal to 32. Well, what number, okay, can give me 32? Well, 2 to the 5th is 32. So base 2, so this has to be in base 2. Okay, same thing here. Well, this is 9 to negative 1/2 exponent is equal to a. Well, negative 1/2. Okay, so what you have to do on this one, a couple ways you can do this, but if I want to take a 1/2 of something, that's the same thing as taking a square root. Okay, what's square root of 9 is 3. But then you got to take it to the bottom, so a is going to be 1/3. And then this one, 9 to what exponent is equal to 3? All right, so how you would do this mathematically, and I can give you the answer real quick, but how you do this mathematically is 9 is the same as 3 squared, right? So this is the same as saying 3 to the 2a, because that's 3 squared is 9 times a, is equal to 3. Well, that 3 actually has an exponent of 1. So if I have the same base, can't I write 2a would then have to equal 1? And divide that by 2. So a is going to be 1/2. A little tricky, but that's how you get to the point. Okay? All right. That's example 4. They can give you some more examples there, and the video in this I think is pretty good. So evaluating common logarithms. Okay. So common log just means it is base 10. Okay, not all logs, it's just base 10. Base 10 is the only common, is what's known as a common log. So we're looking at base 10. So you do the same work in all base 10. Now your calculators, and you all have kind of the same thing I do with calculators, you all have a logarithm on yours, and it's log. It's this button right here. Okay, and it's going to put you in base 10. Some of yours might have it where you can change the base. If so, take advantage of it. If not, all your calculators are at least in base 10, and your phones are going to be in base 10 too, calculators. Okay, so this just talks about using your calculator to do a common log base 10. Okay, and basically what you would do is the following. It says find the equation that figures this in base 10. So what you have to do is you actually have to put this in exponential form. This is base 10. So you got to go 10 to the exponent of 7,482. And then you put that in your calculator and you get that number there. Same thing here. Put 10 to the exponent of this number and you should get that. And you're going to round 4 decimal places. Okay, make sure you're using 4 decimal places, but that is a calculator problem for you. Okay, so that's working that. And again, they want you to be able to find that value what's known as a natural log. So in a natural log, and they use ln, okay, you use this a different type of base. Okay, the base for a natural log is e, okay, which is a number. Okay, the natural log button on your calculator, and they want you to use calculators for this. The natural log is ln. It's right below your log button on most of your calculators. Okay, if not, Google your calculator and I'll show you how to do it. Okay, but e, okay, is the number. Did they give it to us? Nothing here. It's not going to give me. Okay, e. I can't do it today in my calculator. I'm trying to do it real quick for you. Okay, so I'm trying to think, what did they not put in the book? Maybe in the video they do it. So E actually, I'm gonna go up here. I don't know why they didn't give it to you, but E is the number 2.718281882. I think it's 7. It goes on forever. Okay, you don't need to know it because your calculator has it built in. Okay, so to find using your calculator the natural log of 17.32, you simply just throw it into the calculator like this, hit enter, and you get your number. Again, you're going to go 4 decimal places. So it's strictly just calculator stuff. Okay, and you'll be able to get those in here. Okay, now to do solving for the number right here in the natural log, a little bit different. Okay, you have to actually change it to exponential. So you have to change this to e to the 1.335. Now in your calculator, you can do that by doing a second function and then hitting the natural log button which gives it's this button on your calculator, and then what you do is you punch in this number into the parentheses, and it'll give you your answer, and you again put it down into 4 decimal places. So pretty straightforward with your calculator. Okay, and then the last thing we're going to talk about in this is graphing. Okay, so in graphing, your logarithm looks like this. And again, you can put you can graph base 10, and you can graph a natural logarithm. Okay, the only thing you won't be able to graph is different bases. Okay, but you can do a couple things because of their inverses. Your points are going to be a little bit different. Okay, your inverses always switch. So in a logarithm, you're going to have the point 1, 0 instead of 0, 1. Your base is going to come right here. Instead of 1, 2, I have 2, 1, and so this would be base 2 as long as you have a 1 value there. Okay, and so you can actually find your logarithm with that. Okay, trying to graph these. If you actually wanted to graph one of these, you would actually have to switch your logarithm into exponential, and then you can graph it. Okay, and what I mean by that is I want to graph this. What I would do is change this to 2 to the y is equal to x. Okay, and then graph this. And how do I graph it? I pick values for y. You pick these in for y, and you get your x values. So if I do 2 to the negative 1, I get a half. If I do 2 to the 0, I get 1. If I get 2 to the 1, I get 2. And then you get these ordered pairs, which are flipped. And that's how you would graph it by hand. Okay, I'm not going to make you graph things in logarithm, so you're going to be okay. Okay. Besides that, you don't have to know your transformation, so I think we've hit everything for that graph. I hope this helps.